Welcome to the Connect with BMC Helix ITSM and Remedy webinar. During today's webinar, you're able to ask questions of our panelists. The questions and answers, along with the webinar recording, will be published to communities and our YouTube channel a week from today's date. Today's topic is Introduction to Discovery Customization, and Lisa Keeler will take us through this content. Over to you, Lisa.
Thanks, Greg. I am Lisa Keeler. I am a lead technical support analyst, and I've been working with the Discovery product for over 10 years. First, we will cover some concepts which are important for customization. Then we will jump into patterns, not just custom patterns, but also out-of-the-box patterns. BMC Discovery discovers network assets and the software running on them across your enterprise, as well as relationships between those assets. Custom discovery patterns can be used to enhance the discovered data. This webinar is the first in a series of webinars regarding customization. This webinar covers a base of understanding that you will need in order to be able to customize discovery. The second webinar is next month in January, and it will cover the pattern language, which is used to write discovery patterns. Today, you won't learn the pattern language, but you will learn how to read the important pieces of a pattern. Why would you want to customize discovery? Here's some examples. Suppose you want to add some location information to the hosts and devices, or you want to add the ownership or the organization that owns that host or device. Maybe you want data to be presented in a required format. If you want to create a new report based on the current data, then you should be able to just write a query to generate your report. But if you can't create the report because you don't have the data, then you could write a discovery pattern to add the data you need so that then you can create your report. Because of the customization features that are in Discovery, Discovery is a very powerful tool. And my goal with this webinar is to teach you to harness the power of customization. The data store is a graph model. Specifically, it is not relational. Discovery has a proprietary query language, not SQL. You will hear people say the model or the data store interchangeably. The model is the service that supports the data store. The data in the data store is comprised of nodes, attributes, and relationships. All nodes have a node kind. Here are some common node kinds in Discovery, such as host, network device. This node, the Business Application Instance node, we often call it the BAI. It represents a service model or an application. This slide is controversial. The graph data model is not at all like the relational database. However, I find it helpful for people that are familiar with relational terminology to be able to compare their terminology to the terminology that we use in Discovery. So very loosely, we can say there are some similarities. What we call a data store is similar to what would be called a database. What we call a node kind would be called a table definition. A node in Discovery is comprised of attributes, just as a row is comprised of columns. The taxonomy is a description of the data model. The taxonomy describes the node kinds, the attributes for each node kind, and the relationships between the node kinds. In Discovery, the out-of-the-box node kinds are defined in camel case, and the out-of-the-box attributes are lowercase. There are also internal attributes, which have leading underscores at the beginning. It could be 1 underscore or 2. Here are 2 internal attributes, all IP adders and all MAC adders. Relationships have a 4-part description. Here's 2 example relationships. In the first example, this is an example of a traversal from a particular host to the set of software instances that the host is hosting. So it's the software instances running on the host. If there's only one software instance on the host, this traversal will return a list of one. A traversal always returns a list. This second example is a traversal from a particular host to all of the business application instances or applications that the host is part of. Now I will show a demo. I'll look at the taxonomy, some relationships, and the most important thing in the demo will be I will show you how to find a query and how to find relationships that you want to use in your customizations. This is the home page of the Discovery UI. Here in orange, it tells you that I'm using version 12.1. The home page is customizable. You could have different dashboards showing on the home page. But if you don't customize it, this is what is displayed by default. My favorite part of it is this quick view that shows all the different data that you have in Discovery. So I have 307 hosts, 13 network devices, software instances. I have 3,461 of them, etc. Similar to the quick view is a different option. You can go explore data, which is maybe a more exhaustive list. So actually, I often use this page. First, I'm going to show you the taxonomy. And to go to the taxonomy, we click on the gear, which is called administration. And then under the model section, I'm going to click view taxonomy. So there's a lot of clickable links on the taxonomy. Mostly this is a list of nodes, and if you click on a node, you can see the attributes. So I would like to find the host node. So I did a Control F and I'm searching for host on the page. So I found my host node. You notice here that there's a list of nodes all under this managed element grouping. Managed element is like the base class of the host node. The host inherits certain attributes and behaviors from the managed element. So if I click on host, here I see I'm in the host node, and again it shows it's part of the managed element. Here's the list of attributes for the host node. There's host name, and then what this shows here is this is the name of the attribute, the type of the attribute, it's a string, and this name in square braces is the name that will be displayed in the UI. Instead of the lowercase host name, it's going to show host name with an initial cap. But the real attribute name that we have to use in our custom patterns is actually host name, all lowercase. If we scroll down through the large list of attributes, we come to a slightly different list. These are the attributes that were inherited from the managed element. So there's a key. All nodes have a key, or all managed element nodes have a key. Name, which is different from that host name we saw. Description, etc. Keep scrolling and we see that there are relationships for the host node. There are 65 relationships. The ones I had showed you earlier were this one, where we traverse from a host to the business application instance. And I also showed you this one, where we traverse from a host to the software instances that are running on the host. There's a little description of the relationship here, software instances running on this host. And here it was business application instances running on this host. So if I'm writing a custom pattern and I need to traverse from a host to its list of software instances, I could come over to the taxonomy to find how that traversal is done, because I haven't memorized that the relationship is called host : hosted software : running software : software container. There's probably some people that have memorized that, but I don't memorize any of these. I just find what I want. Now, an easier way to find what you want instead of looking at the taxonomy, an easier way, or the way I use, is to build a query. And I get the data I want, and then I look at the query to see what traversal that data came from. So I'm going to go to my Explore Data, and I would like to look at my list of hosts. So I'm going to click on the 307 hosts. And I see my hosts are displayed. And there's a set of default columns that are displayed in the UI. Now, my favorite trick is to click Customize, and this last tab, I can see the query that generated this list. The query is simply search host. Now, why doesn't it have any columns in the query? Well, if you don't provide the column names or the attribute names to show, then there's a set of default attributes defined in the taxonomy. However, it's not something that you can see on the view taxonomy. It's something that is in a file, the taxonomy file itself. What I often do is I'll just add a new attribute, maybe the OS class, and then here's the list of attributes that will be displayed by the query. Let's say I would like to move the OS class up higher, maybe right here, because that makes more sense. And I'm going to refresh the results. So now I have this new attribute called OS class, and I could sort by it to get them in a ordered. So here's all of my Unix hosts at the top. Now that I have added a new attribute, I can look at the raw query and it has changed. So now it says search host show, and then these are the attributes: name, OS class, as OS class, OS, vendor, virtual, partition, cloud. This is interesting. This is a traversal through the discovery access, and then we're traversing from the host to the discovery access, and we're getting the endpoint attribute of the discovery access. And we say that's as scanned via. So the scanned via column, these are the endpoints that we used to discover the host. This isn't necessarily the only IP address on the host, but this is how we scanned it. Okay, now I'm going to simplify how this query looks a little bit. I'm going to get rid of most of the attributes so that I have a simpler query. Now I'll refresh the results. Okay, so I only have 2 attributes on the page, host name and OS class. Now I would like to add the software instances for each host. So I want to find the list of software instances. So here in the customized columns, I already showed you that I can add a column like OS class. But if I scroll down, I see a list of relationships. So let's look for something that pertains to software instances. Okay, here's some. There's software instance : software instances running on this host. Well, that sounds very promising. And then there's aggregate software instances running on this host. Okay, well, I'm going to choose the first one. And then it shows the name here, software instance. This list over here is for host. Now I'm looking in the second window, I'm looking at software instances, and these are the attributes of software instances. There's a name and a type. So now I have added here to the columns displayed the name and the software instance and the type. So now I'm going to refresh results. And now I have host name, OS class, or just name, I should say, OS class, and then something called name, but I happen to know that these are the names of the software instances, and the same for type. Now this is kind of an ugly looking list, but this is a comma separated list of all the software instance names that run on this host. And this is a comma separated list of all the types of the software instances that run on this host. So let's look at the raw query. That's actually why I'm doing this. Here, search host show name OS class. And here I'm traversing. The pound sign signifies the traversal from the host to the software instance here. And I'm getting the name here, dot name. I'm getting the name attribute from the software instance and displaying it as name with a capital N. And then I'm traversing yet again to get the type of the software instance. And I display it as type, uppercase. There are many customization points in Discovery, but I'm focusing on the Discovery patterns. The pattern language is called TPL, for the pattern language, is used to write Discovery patterns, and also it's used to write CMDB sync mappings. Briefly, the CMDB sync mappings control how and what data is put into the CMDB from Discovery during the CMDB sync operation. The out-of-the-box patterns and sync mappings are delivered monthly in a TKU update. Nodes are created in two ways. One way is during Discovery itself, and the second way is during a pattern execution. There are certain nodes that patterns should not create, such as host, network device, printer. These are what we call root nodes. Again, patterns don't create these nodes. Other nodes, such as a discovery run and discovery access, are internal nodes used to describe the discovery itself, and those are also not created by patterns. Many other nodes are created and maintained by patterns, such as software instance, software component, and database nodes. The out-of-the-box patterns create nodes, attributes, and relationships during discovery. Patterns can also add additional attributes to a node, even though the pattern didn't create that node. Many custom patterns do only add attributes to an existing node. Patterns can create new relationships between nodes. Here's an example trigger for a pattern. The trigger is triggering on a host where the host was created or confirmed to exist in the discovery with the OS class equal to Windows. In other words, this pattern will trigger on a Windows host if the host was created during the discovery or it was just found again in the discovery. And next I will show a demo. We will look at an out-of-the-box discovery pattern, and I'm going to show you the important highlights of the pattern and how to read it. Okay, we're going to look at an out-of-the-box pattern for the Apache ActiveMQ. There's a couple of ways to find the pattern. One way would be I could type in ActiveMQ in this search box. It's a global search box. Another way is I could visit the TKU page, so to speak, is under Manage Knowledge. So I'm going to go to the Manage Knowledge page. Here we see the TKU version. I'm also using the extended data pack and the storage TKU. Here are the various patterns that we have. If I type in something in the filter, I can put ActiveMQ to search for the pattern that I would like to look at. Okay, now it found the pattern. So this is the pattern itself. If you look at it, it looks like some code, right? And it is, it's code. It's some software that someone wrote using the split pattern language. Okay. So starting from the top, there's the TPL keyword. The version of the TPL is 1.12. The version of TPL is used to describe what features are in the pattern language. So if I want to use a newer feature, I would have to increment this TPL version. 1.18 is the latest version. But 1.12 contains the features that most people are using, or it certainly contains the features for this pattern, and so it's not necessary to increment the version unless we need to use the newer features. Module is a keyword, and this is the name of the module. Apache.ActiveMQ is the name that someone made up and gave that the module name. Now, inside of this pattern module, there can be one or more patterns. So on line 16, we have the keyword pattern, and then we have the name of the pattern, Apache_ActiveMQ. And then we have the version of the pattern. Now, this is a pattern that is provided in the TKU. It's out of the box, in other words. And engineering writes these patterns, and they maintain the patterns. And when they revise the pattern with a substantial revision, then they increment the version number. At the top of the pattern is a set of required comments. The comments can be enclosed in triple double quotes or triple single quotes. But even if you don't have any comment, you still have to have the triple double quotes or triple single quotes. But between the quotes could be just nothing, but it's still required to be in the pattern. Now, one way to read a pattern is just to read the comments, right? Okay, the next exciting part of this pattern is the trigger. Here we see the trigger for this pattern is on a discovered process. So as discovery runs and it discovers a host, it also discovers all the processes running on that host. So during discovery, when we're discovering a host and we find a process whose command name matches Java and the arguments match ActiveMQ.jar, then this pattern will execute on that discovered process. Now, discovered process with camel case is the name of the node kind that the pattern is triggering on. When it triggers, it's going to create a local variable called process, and the local variable called process points to the discovered process node. So in the pattern, we're not going to be looking at discovered process. We're going to look at the thing called process to see what we want to see. For example, here we're saying process.cmd. We're getting the command of the process. So it's the Java command is the process, and this process invoked the Java command with an ActiveMQ.jar in the argument list. And that's how this pattern decides that it's time to create a software instance for the Apache ActiveMQ. Now, this is funny syntax here, but between percent signs, what we do is we put, so this is a quoted string. It can be single quotes or double quotes, it doesn't matter. It's a quoted string, and inside the string, we're getting the values of some arguments or of some variables. So first, between the percent signs, we're getting the command from the process that we triggered on, this process. And then we have a space, because this is a string. So we have command, like it'll be like Java space activemq.jar, etc. So actually this process.args is all of the arguments, not just the matching argument. So this is just some logic in the pattern that I'm really going to be skipping over. But notice that there are some logging statements. If your logging mode is in debug mode, then you will get these statements in your reasoning log. Sorry, it's not really the reasoning log, it's the reasoning patterns log, which is called ECA patterns. So I guess TW ECA patterns.log. That's the log that you will find the logging statements from patterns. But the most exciting command here in the pattern is right here. We're calling model.softwareinstance. Software instance is the name of the node kind that we wish to create or modify with this statement. So model dot is just that's the name of the function, model dot node kind. So if I wanted to create a host node, which I shouldn't, then I would call model.host. If I want to create a database node, I would call model.database. This pattern is creating a software instance node or updating it. So it calls model.softwareinstance. The arguments to model.softwareinstance here on the left, these are the names of the attributes that the software instance is going to be created with or updated with. So the type, which will be something like Apache MQ, the key, which we are computing using some hashing, the name of the software instance. So all of these values were set earlier in the program, the version, etc. Now, this funny TW metadata adders is an older way to add attributes that the UI should display when we look at the software instance page. So install root is the first attribute and config file is the second attribute. Those attributes are going to be added by this pattern to the display of a software instance. The next one, the next model dot function here is creating a unique relationship, a communication relationship between the client software instance, which was set here. The result of model.softwareinstance is put here in this local variable called SI. And so we're creating a relationship between that SI and the server, which is a different local variable called RDBMS SIs. Now, back to this where we're creating the software instance. The key is very important. Like I said, this model.softwareinstance either creates or updates a software instance. Whether or not it creates or updates it is dictated by the value of the key. If this key is new and we don't have any software instance with this key already, then we'll create a new software instance. But if this key already exists for a software instance, then we will modify the software instance that matches this key. So the key is the magic of determining if we're going to create a software instance or update one. I mentioned that the current TPL version is 1.18, but this pattern is using 1.12. How do we know it's 1.18? Actually, we go to Manage Knowledge page again, and we can see TPL version 1.18. And that's the latest and greatest version. That's the maximum version you can use in your pattern, but you can use earlier versions. Custom patterns can be generated using the Discovery UI, or they can be written in an editor such as Notepad. Most custom patterns simply add functionality. On the other hand, you can have an override pattern that can be used to override the full functionality of the base out-of-the-box pattern. But out-of-the-box patterns should never be modified directly. New software instance patterns can be generated in the Discovery UI at 3 places. One is if you're looking at a list of candidate software instances. Another place is if you're looking at a discovered process or a discovered service. Those indicate that you might have, maybe Discovery isn't creating a software instance for your software, so you can create your own pattern. You can generate your own pattern in the UI to create that software instance for you. So after a pattern is generated, it is also executed, magically creating the software instances for the pattern that you just generated. And now I'm going to show another demo, and we're going to look at the patterns that can be generated in the UI. Okay, I'm going to show you how we can generate a software instance from the UI. So first, I'm going to go to Explore Data and choose the candidate software instances. The candidate software instances are created as Discovery finds services or processes that are running, but it doesn't see that there was a software instance created from that, and it thinks it could be interesting to you. Maybe this is some software that you are interested in and you would like to generate a software instance. So there's a lot of things in this list. I found one that I'm just going to use for the purpose of a demo. This driver. Okay, now I've decided I would like to create a software instance when I see this driver process. So I'm going to click on this, and we can see in the visualization that the candidate software instance has a little question mark inside. So it's saying, did you want this to be a software instance? So there's several of these candidates that are all attached to this host. This is the host in the middle. So you can see this is the host. This is the associated process that's associated to this candidate software instance. Okay, so what I'm going to do to generate the pattern is I'm going to click on Actions, Generate Software Instance Pattern. Now this actually started up at the top. It scrolls down automatically to looking at the conditions under which the pattern should generate a software instance. So the conditions that have been selected by default by Discovery is that the trigger basically will be if the command is this command and the arguments is exactly this argument list. Okay, now I think we should make it a little simpler than this. Maybe we would like this to be the command, but it's not exact. We'll say it contains this, and maybe the argument also contains this. Or maybe we don't need any arguments at all, in which case you could click the little X. So you do have to provide some knowledge to Discovery for when should I create the software instance, right? And what I provided is I said, well, if you see this process with this command embedded in the process command name, and it contains this argument, then generate a software instance. Now at the top, I have to enter more information. So I need to give it a type, and I can optionally provide a publisher, and optionally I can provide a category. So let's say this is, I don't really know much about this at all, but let's say that this is going to be the type VCSAG. And the publisher, it must be Veritas. So let's put Veritas. Category, I don't know. Let's say it's some kind of storage. And it could run on a cluster. Okay, then I can add some attributes of my own. I'm just going to make up some attribute names. Fuzzy bear. is brown. How about fuzzy bear color is brown? I could keep adding attributes. Okay, now if I'm happy with this, I can generate the TPL. Before I generate the TPL, notice down here that as I was changing the arguments in the command values here, this list of things that match was changing. So we have 4 processes that match the criteria that I provided. Okay, now I'm going to generate the TPL, the pattern. Okay, it says the pattern is queued up and it will be under the generated patterns shortly. Now, where are the generated patterns? Right now, I actually don't have any. So, but we'll look for some. We can uncheck these. And after there is a generated pattern, we can click this thing called generated. Let's take this ActiveMQ out of there. Okay, now it's active. So let's look at the active pattern. It's called BCSAG. Let's look at it. Okay, here's the pattern that was generated automatically. I didn't write this. Discovery wrote it. It has some comments. It was generated by the system user because I'm logged in as system. It created its own module name and it created its own pattern name. It created some comments. Comments are very short. Then here's the trigger. Trigger on a discovered process where the command matches this thing with .exe and the args matches this dash type mount v. This question mark I is case insensitive, meaning it doesn't matter what the case is. This is just regular expression syntax. But we're triggering on a discovered process. After we find that discovered process that matches all this criteria, we're setting a local variable called node to be the result, to be the discovered process. It looks like we're not actually using the node, but it's just there. What we're doing is calling model.softwareinstance, just like that out-of-the-box pattern did. So we have a unique key, and so that we're creating a new software instance or we're updating an existing one. We put the type, the name, and there's my fuzzy bear color attribute, which is always brown. And conveniently, they added the fuzzy bear color attribute to the display of that software instance. So let's see if it created the software instances. Let's search for this in the global search. Yes, it did. We have one software instance now that was created from this, from the generated pattern. So now when I look at the visualization, I see this is the host and this BCSAG is the new software instance. And there's a hosting cluster called Tapioca here that we saw here, this cluster that is hosting that software. Here's my fuzzy bear color, which is brown. So this is a software instance page, right? This is my new software instance that was created by the pattern that I generated. Okay, so that's about generated patterns. Okay, if you decide to take on the challenge of writing some custom patterns, where can you get help? Well, There are some pattern templates that are built into the Discovery UI. There is a community patterns page for Discovery. There are some Discovery blogs. You can ask a question in the community. You can open a case with support to ask for help. Depending on what you're asking, we might or might not be able to help you. If your challenge is difficult, then you can contact professional services. If you want help with a custom pattern, it's very important that you should clearly specify what you want to do. Do you want to add some new data to the Discovery data store? Where? What node type? What attribute? Do you want to change the value of an existing attribute, add a new attribute? What do you really want to do? Especially what node type? Do you want to add an attribute to a host, to a software instance, to a database? Or did you want to add some data to the CMDB? And if so, where? Where in the CMDB do you want the data? What class? Is it BMC computer system? BMC operating system? What class is it? And what attribute? Is it an existing attribute or a new attribute where you would like to add the data? Not only where do you want to add the data in the CMDB, but where should we get the data in Discovery? Because we can't add something to the CMDB that's not discovered.
Here are some reference links. The first one is a reference to the pattern language documentation in the Discovery doc. The second link is to the Configipedia homepage. The Configipedia details network devices and software instances that are supported by the TKU each month. There's a link to the candidate software instances and how you use that to generate your patterns for software instances. And finally, there's a link to the patterns page in the Discovery communities. So in summary, we discussed the Discovery data model. We talked about queries. We looked at some out-of-the-box discovery patterns, and we looked at how to generate patterns. I hope that you will join me in January for the next talk in this series when I'm going to cover the pattern language. And that concludes my presentation. Back to you, Greg.
Thank you. And now I'll take us through the self-help in contacting BMC. The YouTube channel where this webinar will be posted is listed here. It contains past webinars as well as a rich set of how-to videos. The Connect with BMC Helix ITSM and Remedy webinar schedule is available at this community's link, and the hot off the press newsletter for trending information is available at this community's post. As always, contacting technical support via web, phone, email, and these social channels is available. At this time, that will conclude this webinar. Thank you for attending.